was buried.
In 2008, scientists switched on the most powerful machine humanity had ever constructed. Within hours, people around the world began asking the same terrifying question: what if this machine accidentally destroys Earth? Our deepest existential dread was suddenly triggered by our greatest scientific achievement. That machine is the Large Hadron Collider, operated by CERN. It sits inside a 17-mile circular concrete tunnel near Geneva, Switzerland. Its primary purpose is to recreate the exact violent conditions that existed fractions of a second after the Big Bang. Mapping the earliest moments of existence required engineers to trigger subatomic violence on a scale never before achieved on Earth. The sheer scale of the project sparked widespread anxiety. Quickly, rumors spread across the early internet, claiming the collider would open portals to strange dimensions or trigger an antimatter catastrophe. The loudest and most specific fear was that a high-energy collision would spawn a microscopic black hole, one that would sink to the Earth's core and devour the planet from the inside out. Because the physics were so difficult to grasp, science fiction easily overwrote scientific reality in the global consciousness. Inside the collider, heavy electromagnets accelerate two beams of protons to nearly the speed of light. Then they are forced into a head-on collision. This diagram illustrates Einstein's famous equation, E equals mc squared, in action. At impact, the intense kinetic energy of those traveling protons converts directly into physical mass. This brief energy spike mimics the extreme temperatures present at the universe's beginning. The public's terror, it turns out, was rooted in a genuine phenomenon. The machine was intentionally designed to break down the normal rules of physics. If matter becomes dense enough, theory suggests its gravity can collapse inward on itself to form an event horizon. The public imagined a worst-case scenario where this new, tiny void would drop straight down to the Earth's core, steadily absorbing matter until nothing was left. While mechanically fascinating, this apocalyptic theory completely ignored the counterbalancing laws of quantum mechanics. Physicists pointed out that thanks to a process known as Hawking radiation, any microscopic black hole would evaporate instantly, vanishing before it could consume a single atom. More importantly, nature bombards Earth's upper atmosphere every single day with deep space cosmic rays. These natural impacts produce collisions vastly stronger than anything CERN could ever generate. The universe itself had already read this exact experiment for billions of years, proving our safety long before the underground machine was built. When the machine turned on and the world didn't end, the paranoia didn't disappear. Instead, it mutated into new digital folklore, like the Mandela effect. Entire internet subcultures began claiming the collider had shifted humanity into an alternate timeline, or that we were now living in a broken simulation. The Large Hadron Collider left the planet perfectly intact, but the paranoia it generated became a permanent fixture of modern internet culture. The true climax of the project arrived in 2012, with the announcement that scientists had finally found the Higgs boson. This image shows the exact computer monitors displaying the colorful, complex particle collision diagrams researchers used as proof. Physicists had searched for decades for this specific particle because it is the exact mechanism that gives all matter in the universe its physical mass. Securing definitive proof brought immense relief to the scientific community. While online forums obsessed over fake doomsday scenarios, thousands of researchers had actually succeeded in explaining why existence itself has substance. The Large Hadron Collider safely achieved exactly what it was designed to do, without opening a single portal or ending the world. But it did reveal something equally unsettling. Humanity now possesses tools powerful enough to artificially replicate the intense conditions that existed in the universe's first moments. The ability to simulate the primal mechanics of the cosmos is no longer a theoretical goal. It is a functional